All right, let's keep doing some more examples with proportions and conversions here, or just answering the unknown piece there. And I have two here that I brought in that are a little bit more application based. And if you need to pause the video to copy them down, because I've already rewritten them, feel free to do that. So the first says, how many milligrams of medication would a vet tech administer to a 95-pound dog if the prescribed dose was 30 milligrams for every 10 pounds? So the dose that we should be using is the 30 milligrams for every 10 pounds, right? So your known here is that we should use 30 milligrams for every 10 pounds. I know that the dog weighs 95 pounds, but I do not know how much of the medication should be in there, right? So X milligrams. And then we follow the same process. So we go ahead, we cross multiply. We end up with 30 times 95 equals 10x. 30 times 95 is going to be 2,850. And then when we divide both sides by 10, I'm going to move over here. We get x is equal to 285. And remember, that was milligrams of medication. It doesn't say what kind it is. For our next example here, again, something similar. We have a lab mixes a 12% solution for a physician. A 12% solution has a 3 to 25 ratio. And then they're going to explain it. So this ratio includes 3 grams of powder for every 25 milliliters of solution. So that's the known ratio, right? We're doing 3 grams per 25 milliliters of solution. And we want to know how many grams of powder will be in 65 milligrams. So if we have to mix it ourselves, for instance, how much should we add? So we know that we're doing 65 milliliters, and we need to know, well, how many grams of powder should there be in that? Again, we're going to go ahead and cross multiply. So we have 3 times 65 equals 25x. And 3 times 65 is going to give us 195. I divide both sides by 25, and I have x equals 7.8. So remember, this was grams, so 7.8 grams of powder in 65 milliliters of solution. And typically, we do use metric forms as decimals. So we can write this as a 7.8. But you could also write it as a fraction, right? That would be 8/10, which would simplify to 4/5. Again, I'm going to leave the decimal here, but you can go back and forth between the two forms as needed. I want to do a couple of examples now that are not application, but that are a little bit messy looking. So these are going to have decimals and fractions, but more than just one. All right, so here's another way we can set up a problem or start it. So we're using ratios, but we're in the form where we're using the colon instead of the fraction. So the first thing that I would do is I would translate these into the fraction form. I think they're much easier to work with. So 0.25 milligrams for 0.8, milliliters. And then 0.125 milligrams for X milliliters. And again, notice that your units are matching, right? Milligrams are on top, milliliters are in the bottom. And we're just going to solve the same way. So even though they're decimals, I'm not going to worry about it. I'm going to use my calculator. I get 0.25 times X, 0.8 times 0.125. When I multiply that out, I actually get 0.1. I divide both sides, and I get 0.4. And remember, we're trying to find our milliliters here. So the answer is 0.4 or 4/10 milliliter. So again, don't get overwhelmed with lots of decimals or fractions. Just use the same strategy. And you know how to work with decimals and fractions. We reviewed that. So you can just keep going. Here's another one. So 1/8 to 1/2, and then 1 to x. Now, sometimes instead of an equal sign, you may see this double colon in the middle. So you want to think of that like your equals there. So our first ratio is 1/8 to 1/2 equals 1 to x. Now, you're just going to be careful. So, you still have two parts, top and bottom, and then you're still going to cross multiply. So we go this way and we go this way. And I'm just going to write it out. So I have 1/8 times x equals 1/2 times 1. Let's just go over here. So we have 1/8 x equals, now 1/2 times 1 is just 1/2. So nothing changes there. Now to solve this, you can do it a couple different ways. For those of you guys who remember your algebra, you may know that you can just multiply by 8 on both sides and cancel out that 8, and that's perfectly fine. If you don't remember your algebra, still think about basic ideas, right? What was our next step when we solve? We always divide by what's with x. So if you divide by 1/8, well, that just means that you're taking 1/2 and you're dividing it by 1/8, which is 1/2 times 8 over 1. Now 8 over 1 times 1/2 is just 8 over 2, which is 4. So we can still solve them. And remember that, dividing by a fraction means that we flip and multiply. So you're just going to apply those rules that you already know when solving. Now, another little trick here, again, for those of you who are more comfortable with algebra, when you have 1/8 x equals 1/2, think about opposites. If I want to cancel 1 over 8, the opposite or flipped version of that is 8 over 1. So you can kind of do a little shortcut there because that will cancel out both sides. And now you're still left with 8/2 or 4. So it's the same exact process of multiplying by 8 over 1. It's just that we're kind of doing it quicker over here. So you're more than welcome to use either strategy. Again, if you forget, just remember dividing by fractions just means to multiply and flip. All right, let's do one more like this. 1 over 16 is to 1.6. And then 1 over 8 is 2x. And again, remember that double colon can also stand for your equal sign. So we have 1 over 16 and then 1.6 as the first ratio. And then I have 1 over 8 to x as my second ratio. And it looks kind of weird, but I'm not going to worry about it. I'm just going to set it up, do my cross multiply. So here I get 1 over 16x is equal to 1.6 times 1 over 8. I get 1 over 16x. Now here I just multiplied straight across. I just wrote it as 1.6 over 8, right? 1.6 times 1 is just 1.6. 1 times 8 is just 8. And then I just went ahead and I used that same strategy I just did. I said, okay, well, I need to get rid of this 1 over 16. We typically divide by that on both sides. But what does that mean? That means we're taking that 1.6 over 8 and we're actually multiplying it by 6 over 1, right? Because dividing means we're going to multiply and flip. And then I can go ahead. Oops, forgot that should be a 16 there. Sorry about that, guys. 16. So I flip that to 16 over 1, excuse me. And then I can just multiply. So I do see a little bit of simplifying I can do here. I can divide those both by 8. And then when I multiply straight across, 1.6 times 2 is 3.2. 1 times 1 is 1. And I just get 3.2. So my value here is 3.2. So I just take a little bit more time with these, just watch my multiplying. It's easy to make a mistake like I did, just, lose something along the way. There's a few more steps. But that's one way you can do it. Another way you can do it, if you like, if you don't like having the mixed fractions and decimals, notice that most of my work is in fractions. So I could change that 1.6 to a mixed number instead. So that's 1 and then 6/10, right? Because I have 1 0 there, one place, or 1 3/5. So instead, if I wanted to, I could go ahead and use 8/5 in my problem. And then I would have 1/16 over 8/5 is equal to 1/8 over x. And then you're still going to cross multiply here. You'd have 1/16x is equal to 8/5 times 1/8. You'll probably notice that those 8s will cancel. So you have 1/16 is equal to 1/5. And then you're getting the same process here. So you're going to divide both sides by 16 still, which means that you're going to end up multiplying by 16 over 1, right? And then if you look at this here, this just becomes 16 over 5. 5 goes into 16 3 times, which is 15 and 1 left over. So I have 3 and 1/5, which is also the same thing as 3.2. 1 divided by 5 is 0.2. So it's just another way that you can do it. And keep in mind, there's often more than one strategy. So there's not always one right way. If you don't like having mixed decimals and fractions, you can try to use them all in the same form. I would just be careful if you're going to a decimal form, if the decimal does not come out like even, if it was a repeat or something really messy, I wouldn't recommend that. I would leave it as the fraction then and go the other way. But otherwise, both forms tend to be good.